In this problem, we need to verify that a point P is going to lie on the circle whenever the length of the tangent from the point P to the circle x squared plus y squared equals to a squared is 4 times the length of the tangent from point P to the circle x minus a whole squared plus y squared equals a squared. Let us begin. So here, let's try to understand it graphically. If we have a point P, we're going to label this point as point H, comma, K. Let's say we have a circle whose equation is x squared plus y squared equals to a squared. Now from point P, let's say we draw a tangent to the circle at point A. And then we have another circle with the equation x minus a whole squared plus y squared equals to a squared. Now we also draw another tangent from the same point P on the circle such that it meets the circle at point P. Now it's given here that PA, the length of the tangent PA, is going to be equals to 4 times the length of the tangent PB. This is given to us. Using this information, we need to show that this particular point P lies on this circle. So let us begin. So here we'll be needing to find out the length of the tangents PA as well as PP. So let's recap the formula that we will be using here. Suppose we have a circle which is centered at G with the coordinates negative G, comma, negative F. And then we have a point P with the coordinates x1, comma, y1, which is exterior to the circle. And from point P, we're going to draw a tangent to the circle at A. Now the length of PA will be given by the square root of x1 squared plus y1 squared plus 2gx1 plus 2fy1 plus c. Okay, so we'll be using this formula to find out the length PA as well as the length of PP. Now in a case, we will start with the equation of the circle A. So it's given to us the equation of the circle, which is x squared plus y squared equals to a squared, but we'll transpose a squared to the left hand side equals to 0. And what we'll do, we'll compare this equation with the general equation of a circle, which is given by x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. In doing so, we get the value of 2g. So 2g will be equals to 0. The value of 2f will be 0 as well. And the value of c is going to be negative a squared. Now, from the point P, which has the coordinate h, comma, k, the distance of the tangent, the length of the tangent PA measured from P will be equals to, we'll take the square root, so we need x1 squared. So here x1 will be nothing but the point x coordinate of point P. So we have h squared added to y1 squared, so y1 will be the y coordinate of point P, so that's k squared. Then we have 2gx. Now here 2g is 0, so we don't have to worry about it. Similarly, 2f is also 0. Now we have c, so c value is negative a squared. So this is the length of PA. So let's label this as number 1. Next, we'll try to find out the length PB. So here we'll use this circle. We have x minus a whole squared plus y squared equals to a squared. Expanding x minus a whole squared gives us x squared minus 2ax plus a squared plus y squared equals to a squared. Here we can cancel out a squared from both sides, and that's going to give us x squared plus y squared minus 2ax equals to 0. Now if we compare it with the general equation, then we're going to get 2g will be equals to negative 2a. Then we have 2f, so 2f will be equals to 0, and the c value comes out to be 0 as well. Now the length of the tangent PB is going to be equals to, we have h squared plus k squared plus 2gx, so 2g will be negative 2a, multiply to x, x is nothing but the x coordinate of the point P, so that's h. Then we have 2f, that's 0, and we have c, that's 0 as well. So this is going to be the length of PB. Now that we have the length of PA and PB, so let's use this condition that PA equals 4 times PB. We have PA equals 4 times PB. Squaring both sides gives us PA squared equals to 16 times PB squared. So PA squared will be simply h squared plus k squared minus a squared equals to 16 times PB squared. So that will be h squared plus k squared minus 2ah. So let's simplify this. Now we will get h squared plus k squared minus a squared equals to 16kh squared plus 16k squared minus 16 times 232 ah. So 16h squared minus h squared, that will be 15h squared. 16k squared minus k squared will be positive 15k squared. Then we have negative 32 ah plus a squared equals to 0. Fine. Now what we'll do, we'll replace the value of h with x and the value of k with y, and then our equation was going to become 15x squared plus 15y squared minus 32ax plus a squared equals to 0. This only tells us that the point P having the coordinates h comma k lie on the circle. That's what it means, and we have finally showed that that's the truth. So let's compare. So we had to show that the point h comma k lies on 15x squared plus 15y squared minus 32ax plus a squared equals to 0, hence proved.